Back again with our third and final sample problem from section 2.5. I am just going ahead and doing these one at a time so you can say, oh, okay, if I want to look up a distance problem or a time problem or some other type of a problem, then you only have to watch one of those. But before we get started, can you tell me what the windshield said to the bug? I bet you don't have the guts to do that again. So, what we have right here is the absolute value of x is equal to 5, right? Well, what this means is that some point x is 5 units from 0 on the number line. What this means right here, if we have something like this, the absolute value of x minus 1 is equal to 4. What this means is the distance from some point x to 1 is 4. This was the distance from some point x to 0 on the number line is 5, and that was how we worked with our definition of absolute value, saying absolute value is the distance from 0. But this right here is the distance to a positive 1 on the number line is 4. This is the distance to a negative 1 on the number line is 4. And this is what we covered a few videos back when we were talking about section 2.4. And this is the one that I told you on Tuesday I would spend the time illustrating the problem to you on video so that you would be able to go back and re-record it. So this is what we're going to be dealing with in problem number 3. And this is definitely not an Algebra 1 problem. We didn't do anything like these last year because we didn't have to come up with or create absolute value equations. But what this problem is talking about, it says you've got a marble. And the marble is 3 inches from the 8-inch mark on the ruler. And they want to know, okay, that would be 6, and that would be 3, 1, 2, well, here's the 8-inch mark on the ruler. And it's telling you that the marble is going to be 3 inches from that 8-inch mark. So where's it going to be? Well, we know that the marble can either be over here at 5 inches, or it can be over here at 11 inches. That just makes sense. We don't need to come up with an absolute value equation to know that the marble can either be at 5 inches or it can be at 11 inches. However, if you just say, well, here's my picture, just go, that's not enough to satisfy your Algebra 2 teacher. So you've got to come up with an absolute value equation. So what this is simply the distance from 8 on the number line, or the distance from 8 is 3. Remember that when we set up these absolute value equations, that the distance here that we're talking about, the distance from the number, the sign is opposite. Now we have this equation. Remember how you solve absolute value equations? You have the first one, you just drop the absolute value bars, or drop the absolute value bars and set it equal to the opposite. We add 8 to both sides of the equation, 3 plus 8, and we have x is equal to 11. Or we add 8 to both sides of the equation again, and you have x is equal to 5. Which of course is exactly what we were able to say just by, okay, if I'm at 8 and I go 3 inches away that way, 3 inches away that way, I'm at 5 inches and 11 inches. But you have solved this by using an absolute value equation. The distance from 8, you know, the distance of some number from 8 is 3. And what are those two numbers? The distance of x from 8 is 3. X can be either 11 or x can be equal to 5. Now let me go ahead, I said I was just going to do one problem. Let me go ahead and look in the book and let's do another one of these absolute value equations. Another one or two, since they seem to be a little bit different than, since they're definitely a little bit different than what we've been doing. So let me turn over here to the next page. This is section C, absolute value equations. And I asked for you to do number 17. So let me go ahead and do number 19. Let me see if I can do this. And one thing that I haven't mentioned is anytime that you're solving these equations, anytime you solve a word problem, when you get an answer and you're going back and checking it, you also have to see, does this answer make sense? For example, if on the problem earlier with Ted and Jeff a couple of videos ago, we said Jeff was going negative 23 miles an hour. Is that a logical speed? No, it's not a logical speed. Is it a logical answer up here with our problem about the location of the marble on the ruler, that marble would be at -1 inch? No, our rulers are only positive distance. So this is something that we're going to pay attention to with on problem number 19. This says Kevin is hiking the Appalachian Trail this summer. He begins at Springer Mountain, Georgia, which is the start of the trail. Okay, so if you're starting, this is the start of the trail, and here's the finish of the trail up somewhere in Maine or wherever it is. And they're going to have mile markers along this trail. What mile marker do we have here at the start? Exactly, you have 0 mile marker. You have your 0 mile marker. Marker. So let's read the problem. Kevin is hiking the Appalachian Trail this summer. He begins at Springer Mountain, Georgia, which is the start of the trail. Today he saw a sign for Newfound Gap 17 miles ahead. If Newfound Gap is the 230-mile mark of the trail, where is he? Okay, he saw a sign 17 miles ahead is Newfound Gap. Okay, so we have 17 miles and Newfound Gap is at 230 mile, at mile marker 230. So the distance from 230 is 17. Okay, let's go ahead and see what we end up with. Remember, Newfound Gap, he's 17 miles away from it. That's the distance. Absolute value is distance. So the distance from 230 is 17 miles. We're going to solve our absolute value equation, remove the absolute value bars, have that equal to the positive, or we can remove the absolute value bars and we can have that equal to the negative. We add 230 to both sides of the equation. X is equal to 17 plus 230. X is equal to 247. Now we're going to add 230 here. X is equal to negative 17 plus 230 gives us a value of x is equal to 213. Now these are mile markers. Now what's our answer going to be? We know he's hiking. So both of these can't be true, can they? He can't be at mile marker 247 and he can't be at mile marker 213 at the same time. So even though both of these values here, 247 and 213, both meet the mathematical requirements of this absolute value equation here. It doesn't work for the word problem because, you know, God has not made us, no matter how much we try. We, as human beings, cannot be in two places at the same time. It is a physical impossibility. You know, videos don't count, okay? You know, you can't clone me and put me one place and another place and have it actually be me, okay? So which one of these is the correct answer? Is it 247, is it mile marker 247, or is it mile marker 213? And how would you know? Well, you know by that little piece of information that says he started at Springer Falls, or wherever it was, Springer Spring, which was in Georgia, was the start of the trail. When you begin something that is a measured distance, the beginning is 0, unless they tell you that you're beginning at the end and you're working backwards. When you're measuring distance and they tell you you start at the beginning, you are starting at 0. So if he is passing a sign that says 17 miles ahead is Newfound Gap, well, right here he started at 0 and he's going this way. Newfound Gap is 230 and he has 17 miles to go until he gets there. So by context, he has to be at mile marker 213. Now, if he had begun in the northeast and was coming back down, traveling in this direction, and he saw the sign that said that Newfound Gap was 17 miles, then he would have been at mile marker 247. But because he began at the beginning, at mile marker 0, he saw the sign that says 17 miles on up ahead is Newfound Gap at 230. We've solved our absolute value equation, and we can say that by context, the answer has to be that he's at mile marker 213. And that's the end of the videos that I'm going to do for section 2.5.